Hello, everyone. Everyone did, almost everyone did very poorly on quiz number three of CCCS122 Discrete Mathematics. So I thought I'd walk you through the solution very quickly. This is quiz three, and had had five problems. The first one was this one over here with the pseudocode, and we have a variable in here that is initialized to zero, and we have two nested loops, this one and this one. And inside the two nested loops, the first time and the second time, we are adding 1 to the value of k. And the question is, what is the value of k going to be by the time we exit or complete running the code? And for nested loops, the only thing for the first two nested loops that you have to ask yourself is, how many times do we get to this line of code? And the answer is pretty simple: as many times as we run the outer loop, this one, multiplied by the number of times we run the inner loop. This is basically what you know from programming courses. So the first loop runs for n1 iterations. This inner loop runs for n2 iterations, which means we get to this incrementation code, we get to it n1 times n2 times. And after we get out of these two nested loops, we see another two nested loops. Now, in this one, the outer loop runs n2 times, the inner loop runs n1 times. Now, it doesn't really matter in which order this happens, because what's happening on the inside is still the same. We're incrementing the value of k by 1, which means we get to this line of code n2 times n1 times, which is the same that we have from the first set of nested loops, which means in total the value of k will be 2 times n1 times n2. Now, I took 2 minutes to explain this. This was something that you should have seen immediately and done like 5 seconds, 10 seconds. All right. Problem 2 is related to the pigeonhole principle. So we have a drawer, and there was a very similar problem in our lecture. I think where we had a drawer of socks containing of 2 different colors. In this one, we have 3 different colors. We've got 12 brown socks, 12 black socks, and 12 white socks. And the question is, it's dark. How many? And the question is exactly the same as in the example. How many socks would you have to pick out of the drawer to ensure you have at least 1 pair? So we have 3 categories, 3 pigeonholes. We have plenty of socks of each color, which means we need 3 plus 1 socks, and that's the answer, 4, in order to make sure that we have at least 1 matching pair. Then we have problem 3, robotics club. We have to select a team of out of 10 female. A club has 10 female and 6 male members. Out of those, we have to pick 5 female and 3 male members. How many ways are there to build a team for that competition? So when you pick a team, it does not matter who you pick first, who you pick second, who you pick third. So we have which means we are interested in the number of combinations, not permutations. The order does not matter. Remember, that was the main difference between combinations and permutations. So how many ways are there to pick 5 members out of a group of 10? The answer is C10-5. And how many ways are there to pick 3 members out of a group of 5 and 6? Okay, so a small mistake. I'll fix that. How many ways are there to pick 3 members out of... No, that's right. 6. Okay. How many ways are there to pick 3 members out of 6 male members? And the answer is The answer is C63. Yeah, so that's right, actually. I thought I made a mistake, but I didn't. Okay, so the first one is 10 factorial divided by 10 minus 5 factorial, 5 factorial. The second term is 6 factorial divided by 6 minus 3 factorial times 3 factorial. Simplify that a little bit, we can expand the 10 factorial into 10 times 9 times 8, 7, 6, 5 factorial, which we only expand up to 5 factorial because we want to cancel it with either one of these 5 factorials, which is what we do. And for the second term, we expand the 6 factorial to 6 times 5 times 4 up to 3 factorial because we're going to use that to cancel out with one of the 3 factorials that we have in the denominator. You do that, you rewrite what you have, all the remaining terms that you have over here, you rewrite them. That's what you see over here. And then you just break out a calculator and find the answer. So 5 factorial is 120, 3 times 2 is 6, and then you take the product of everything you have up here, and that is 3,628,800. Do the division on your calculator and you get 5,040, and 5,040 possible teams. That's the answer. We have problem 4. In this one we have a photographer has to take a group photo of teachers and students at a school. We have 5 teachers that will sit in the front row, so that will not change, and we have a second row of standing students in the photo. 7 of those students. In how many ways can you arrange these the people in the picture? Well, this is straightforward. We can have 5 people for the first chair for the first chair for teachers, 4 remaining teachers for the second chair, 3 for the next chair, 2 for the second last chair, and only 1 teacher left for the last chair. So 5 factorial ways to arrange teachers. And by the same logic, there will be 7 factorial ways to arrange students standing behind the teachers, which means in total, the number of arrangements is 5 factorial times 7 factorial, or 120 times 5,040, which comes out to 604,800. Again, this jump you make with a calculator. Then we have the last problem, problem 5. A store manager at Jareer has to arrange 6 out of 10 new phones that he has. How many different ways can he arrange the display? So this is something in which the order will matter, right? So in how many ways can you arrange 6 items out of a set of 10 where the order matters? And the answer for that comes from permutation, which means 10 factorial divided by 10 minus 6 factorial. Take the 10 factorial, expand it, we get 4 factorial here at the bottom. We expand 10 factorial until the 4 factorial term, so we can easily cancel it out. And the terms that we have left, just use a calculator, take the product, and you get 151,200. And that's the answer to problem 5. And that's it. If you know what you're doing, this was like a 5, 6, 7, 8 minute job.